Alright, first step that I'm going to do here, again, is just going to involve rewriting this. First of all, you definitely got to know with the radical, you got to rewrite your radical. So we'd have 1 over x squared minus 2, and this would now be to the 1/2 power. Now, if you leave this as it is, then, of course, you're going to do 1/2, you'd bring that to the front, times this to 1 less power, and when you got ready to do the derivative of the inside, see, this would be the inside part. Leaving it this way, you would have to do quotient rule, which again would work, but it's going to be a little bit more work that you would have to do. Here's what I would suggest on this one. This x squared minus 2, let me get this pen. You could, of course, put an exponent on all of this, which means it would be understood to be to the 1st power. So if I did that, of course, I'm going to take this and move it to the top, which this 1 I wouldn't have to write because 1 times, would be redundant. So I'm going to move it to the top, which would give me a -1, but then all of this is still to the 1/2 power. Now you have a power to a power, so just applying your exponent rules, power to a power, you would multiply those. So I have x squared minus 2 to the -1/2. So I would use this to take my derivative, and by doing these steps you completely avoid, again, quotient rule. Alright, so starting out with power rule, you have your power times your function to 1 less power, and then you have to multiply by the derivative of the inside, so the derivative of x squared minus 2 would be 2x. Okay, simplifying this, what's going to happen is your 2's are going to cancel out. So let's just go ahead and cancel those and get those out of the way. So that's going to leave me with -1 times x, so that's going to be a -x. But then I'm going to want to move this portion of it to my denominator so that my answer will be written with a positive exponent. So again, the key to lots of these problems is recognizing what you can do as far as rewriting. Okay, next. Okay, the only rewriting that you're going to want to do here, of course, is with the radical. So we have 1/2 x squared times 16 minus x squared to the 1/2. Now, you're going to have to use product rule on this one because the 1/2 x squared would be considered your first function, and the parentheses to the 1/2 would be considered your second function. You can't distribute this, because this being to the 1/2 power. If this were just to the 1st power, then yeah, take it, distribute, and you wouldn't have to do product rule, but that's the direction we're going to have to go here. So dy dx, or y prime. Alright, so product rule, you would do first function times the derivative of the second. Now I'm going to use a bracket here. Of course, this would indicate the multiplication. But I've got to take the derivative of the second function. This is where your chain rule is going to come in. So you have to do 1/2 times your function to 1 less power. And I just switched over to putting all that in a bracket because I knew I'd have another set of parentheses there. Okay, plus, so now you take your second function times the derivative of the first. So we've got to do the derivative here. So I would have the 1/2 is a constant multiple, so I'd have 1/2 times 2x. Of course, that would drop to the 1st power. Okay. Multiplying what we can here, you can of course go ahead and do the 1/2 times the 1/2. So I'll have 1/4 x squared times the 16 minus x squared to the -1/2 plus course, here what's going to happen is that's going to cancel, and we just have x times 16 minus x squared to the 1/2. Okay. Now, what you've got to look for is to see if you have any common factors here. Well, before I say that, you can go ahead and take this and move this to the denominator, but that's only going to be with just this portion. Because like for you to put any of this together, like once you move that to the bottom, you'd have to get a common denominator. What I suggest you do is factor out a GCF. Okay. First of all, you do have an x in common, so we know we can factor that out. Now, you've got these in common. Now, I know you're not used to taking out GCFs like when you have fractional exponents, but if you just go back, let me just give you a quick refresher here. Like if you have, 2x squared plus 3x. Of course, they've got an x in common. What you always bring out is always going to be the smaller exponent. Like this is to the first power, okay? So, the smaller exponent that you have here would be the negative 1/2. So, you're going to factor out 16 minus x squared to the negative 1/2 power. And then you write down what's left over, okay? Alright, so you're still going to have your 1/4 here, and you'll still have an x. Of course, this is gone now because that's exactly what you're factoring out. Alright, plus sign. Of course, this x is gone. Now, you're taking this from this, okay? Now, to figure out what's left over, always do this exponent, whatever you have here, minus what you're bringing out. So 1/2 minus a negative 1/2 is just positive 1. So that means that you're just left with 16 minus x squared to the first power. Of course, since this is a first power, you actually wouldn't even have to put your parentheses there. Okay. Now, you do need to move this to the denominator now. So what I'm going to have on the top, I'm going to have the x times, and I've got the 1/4 x plus the 16 minus x squared. I'm going to go ahead and drop the parentheses there. And that's all over 16 minus x squared, of course now, which is to the positive 1/2 power. Okay, let's distribute the x. Okay. And actually, yeah, I was going to say we didn't have to do that, but that would be the best thing. Go ahead and distribute the x. Now, you actually still have a complex fraction here because you have this little fraction, inside the big fraction here. So, since your denominator is 4, I'm going to go through and multiply everything by 4. So, all 3 terms here and the term that's on the bottom. Alright, so of course if I multiply this times 4, the 4's cancel and I'm just left with x squared. And that'll now give me a 64x minus 4x cubed. And then this would just be 4 times 16 minus x squared to the 1/2 power. Now I'm sure the answer in the book would write this in descending order and have this term first. This term, and then this term. But that would be fine leaving it there. Okay, next one. Alright, what you're going to want to do here, of course, is change this to a 1/2 power. And you can leave it and use quotient rule, or if you want to bring it to the top and use product rule. You can do it either way. Since we just did one with product rule, I'm just going to leave it and let's just go with quotient rule this time. But there would be nothing wrong. Bring it to the top and make it to the negative 1/2 and go with product rule. Alright, so we're going to do quotient this time. Alright, so this would be low D high minus high D low. Now when you do the D low, which means derivative of the bottom, this is where your chain rule is going to come in. So you have to do 1/2 times your function to 1 less power times the derivative of the inside. So the derivative of this would be this. And that's all over your denominator squared. So it's to the 1/2, and then you square that. Okay, so getting this simplified, as I've said, that's the hard part of all of these problems. Of course, this is just times 1. So that's not going to change. Okay, minus. Alright, a little bit of simplifying right here. This 2 will cancel, go into the 4 2 times. So that would leave us with just a 2. And then you could do the x times the x cubed, get x to the 4th, times x to the 4th plus 4 to the negative 1/2. Now here you have a power to a power, so go ahead and multiply. So 1/2 times 2 is just 1. So that means you just have this to the first power now. Okay? Alright. What you're going to need to do, what we did a while ago, you have x to the 4th plus 4 that's in common. Like all of this is one term, all of this. This is what's in common. So you need to factor that out and bring it out front. Now remember, it's always going to be the smaller exponent, which is the negative 1/2. So you're going to factor out front x to the 4th plus 4 to the negative 1/2. And then you write down what's left over. Okay, so when I factor negative 1/2 from the 1/2, you remember you always do this power minus this power. So 1/2 minus negative 1/2 is just to the first power. Now I'm not going to bother putting that in parentheses to the first power. Okay, you wouldn't have to do that. Minus. Now all of this is gone because that's what you're factoring out front. So that would just leave you with the 2x to the 4th. Okay, I'm going to still put this 1 here because we're going to need to remember that that is an understood 1 in just a second. Okay, you will be able to do combine like terms in here, which I'll take care of that in just a second. Now, the reason why you definitely had to bring this out front is because this is the same as this, and now you can do some reducing with that. Now, when you're dividing out factors, you're supposed to subtract your exponents. So you've got to do negative 1/2 minus 1. Okay, so negative 1/2 minus 1 is going to give you negative 3/2. So what you have because like I said, you're doing this one minus this one. That's just your exponent rules. When you're dividing, you subtract top minus bottom. Okay, and as I told you, you will go ahead and combine these, which will give us a negative 1x to the 4th plus 4. Now, and you could have, this next step I'm going to take, you could actually have done already. When you subtracted here, because that ends up being negative, you're going to end up needing to put that on the bottom, and you could have gone ahead and done that. So this is all that's going to be left on the top, and now you'll have x to the 4th plus 4 to the positive 3/2. This is going to be your final answer.